from Online Acoustics. Today's topic is predicting the diffusion characteristics of diffusers. We are going to use a software called Reflex from a German company, AFMG. There's two versions of the software. One is the basic version, which is the version that I'm using now, and that is restricted to 20 elements. And the standard version is has unlimited elements. I think there's also a professional version, but I'm not really aware of the characteristics. So this is the main window of the software. I already load a diffuser that I've made. This is a KRD style diffuser with 17 wells, no fins. And as you can see, here's the diffuser over here with different characteristics. In this case, the diffuser has maximum depth 15 centimeters and the width is 5 centimeters. So I've made everything here, and we can see here the, let me see if I can hold on. Okay, so here we have the scattering, which is a blue line, and diffusion coefficient. Usually the scattering coefficient is the coefficient that you use for acoustical modeling in the softwares like Audion or OrCat. And here we have the, let me see if I can show you this. Hold on, let me. Okay, so here we have the power response for 1000 hertz, so 1 kilohertz for the diffuser. Now, of course, I can model different frequencies and I can create different kind of diffusers. So if I go over here to properties, I can have like multiple frequencies. Let me see if I can. Just give me 1 second. Scale to fit. Oh, well, not this one. Okay, no, sorry. Got it. So this is the diffuser at the maximum view. I'm just trying to pull the spatial response to a larger window. Not sure why this is like blocking. Let me just throw my camera over here. Okay, so we can add different frequencies. For instance, 500 hertz, and now let's add another one like 2000 hertz. And as you can see, the software has different polar responses according to the frequency. Of course, then we can do averaging. We can there's other options over here that we can use. We also can use multiple angles. For instance, let's like this, and let's see it like I don't know, 60. So here's the power response of the diffuser using different angles. So usually the norm is 45. So now we can decrease this. So this is very, as you can see, this is a very straightforward, very easy software to use. Now I'm going to show you a couple of more tools that we can use, and I'm also going to load a couple of other type of diffusers. So for instance, let's add a diffuser. Okay, I'm not going to save this. Let's add a KRD Okay, so this is the problem with my license because it shows that the maximum amount of elements is 20. So the structure is truncated because even the fins are considered elements. So what I'm going to do, I'm just going to try to run um, maybe a different diffuser. Okay, I don't have diffusers. Okay, 6 periods, so be it. So this is our diffuser with the fins, as you can see. This is one of the models that come with the software, and we can model we cannot model the material of the fins, but we just can model the thickness. Of course, if we change the thickness of the fins, it's going to change the spatial response of the diffuser. Now, this is a very straightforward type of diffuser, but of course we can actually create other types of diffusers. So we can create polycylinder diffusers over here, and of course the frequency response has changed. And keep in mind that this diffuser also has some things over here. So this is a 6-period diffuser. Let's go to fit. And the diffuser has 60 centimeters width with 10 centimeters depth. Now we can do other types of diffusers. For instance, we can do triangles. Let's run a 9-period. Okay, this is our diffuser using triangles. And we can also do semi-ellipses. Let's run this one over here as well. So this is another one. So this is actually the polycylinder, not the other one that I showed you before. So this is an array of polycylinders with fins, and of course I can choose one of these elements. And let's say that I want to change the width of this element over here to 30 centimeters. Okay, it's possible to do this, and I can also change the depth. So maybe I want to create a more chaotic. I want to create a more chaotic diffuser, and so of course I can change all these elements over here. I also can select the fin, and okay, this is 1 centimeter fin, which is great, but if I want I can change the thickness of the fins as well. So this is a very very simple and very versatile software to use. So I can create a diffuser with different elements. So this is a kind of a bit weird kind of diffuser. Okay. Now let me see if I can run. So I've showed you the triangles, the polycylinders, the normal QRDs. There's no more examples here. So what I'm going to do, I'm going to create a new diffuser. And let's say that I'm going to create 15 elements, and I need to choose the. So I need to choose the type of elements that I'm going to use. So let's say that I'm using triangles, and let's say the depth. I want to make a great diffuser, so I make 25 centimeters. Let's leave everything like that. So here we have our diffuser. And of course I can change all these parameters over here. Maybe I want to add some kind of, maybe increase the scattering by creating more randomness. And some stuff that I didn't show you as well is the room outline, which is over here. So basically this spatial plot prediction is based on this kind of element over here. So we have our speakers, there's the listener, speaker, left speaker, right speaker, and we have our diffuser over here. Okay. We can even change our elements here by, which I find it quite difficult to actually work over here. I prefer to actually work with a larger window. But here, what we can do is basically change the characteristics of the room, and then it will also change the spatial response of the room. So this is a square room. Maybe I want a larger room, let's say 8 by 6. And as you can see, it's changing, and I want my origin to be centered. Now I want my okay. Now I want to change this to the correct values. So maybe I want to place one of the speakers here and the other over here. So I can change the position of the speakers over here. So let's say 3.7. Okay. So let's put 3 meters. Maybe it makes more sense than 3.7. And also very important. I also can change the location of my diffuser in the room. So let's keep it centered because that's usually what I want. This is not actually aiming quite straightforward. So let me change this. Okay, no, it's changing on the wrong dimensions. So let's put maybe 4. Okay. So something like this would make sense for a larger type of room. And of course, I can change the characteristics. I also can change the listener position. So this is relative to the room. So I can shift the listener to the left side or to the right side. Sorry, right side, I need to put something larger. To the right side, like this. Or I can just keep it at the center, and also I can change where I want to place my listener. Do I want to place the listener at the specific sweet spot position, or do I want to put my listener close to the diffuser? So if I maybe 20%, and it's the listener, it's coming closer to the diffuser. So let's keep it at 40, which makes more sense. And this version over here. Okay, this version over here is okay. So as you can see, you change the characteristics of the position of the speakers and the listener, and you change the dimensions of the room, and it affects also the power response of the diffuser. Now going back to my diffuser, to the design, I can also, as you can see, I can also shift or flip one of the position of the elements. So I can choose one of this section over here, and if I click over here, now I'm changing the characteristics to something even more chaotic, so to say. Now this is a very very artistic and very weird kind of diffuser that urea. So as you can see, the possibilities are endless. There's one thing that the software does not do, at least this version does not do, which is to mix different type of elements. So I need to choose first which kind of element I want to use. If it's a triangle, rectangle, if it's a circular shaped element, or if it's sign shaped element. So there's not much information over here. We can see the properties. Let me now run the camera over here, over to this side over here. And I'm not sure if I can see the, oh, over here we can also can change the characteristics here of the of our scattering and diffusion coefficients over here. So I can change the range. I think this is typical range, or 100 to 4,000, maybe 8,000, just to give you information at the higher frequencies. Okay. I can choose diffuse field if I want, or I can choose the direction of incidence to a specific degree. Not sure why this is not plotting. Strange. I'm not sure why this is not plotting. Okay, let's keep it unidirectional. So now I'm running three lines, which is the scattering coefficient, the normalized diffusion, and the diffusion coefficient, basically. And this is now it's taking a very long time because I'm averaging points. So if I run like this, it's going to be much faster. And also I have changed the resolution. I don't think this is actually necessary because most softwares actually don't. Most softwares actually don't model to this kind of resolution. So, for instance, in CAT, which is a software I use, they use octave bands for absorption and scattering. So it's more than enough. Single. Okay, now it's making the. It's taking a longer time because it's calculating the information for the diffuse field. For these coefficients over here. Of course, you can save the pictures if it's not crashing. Software now is a bit slow, but I can save the picture to my computer of all these elements. So if I want to make a report or something like that, I can use all this information. And let's see if I can show you to end this. Well, I'm not going to save this one. Okay. Yeah, of course it's truncated, but I need to. It's truncated to a fewer elements over here. So let's set six periods and the respective things over here, which is less than 10 elements. And now it's taking too long. Okay, if I do this unidirectional, the information it's faster to run. Oh, another thing. So of course, I can also use my mouse to control these elements over here for faster editing. So maybe I want to do this, and now I want to. Oh, it's not increasing the depth of the diffuser because maybe when I created this element, or when someone has created this diffuser over here, they have stipulated the maximum depth of the diffuser. So I cannot actually push the depth further down to the specific limit that I have created when I started the diffuser. Oh no, I can't. Sorry about that. Actually, I can do this button over here. I was not really aware of this. Usually, I use this table over here to change the characteristics. So I can change the diffuser. I can change these elements over here as well. So as you can see, I'm changing two elements over here. I'm changing this element over here, and then I'm changing the curvature of the diffuser. I can also change, of course, the thickness. the width of the diffuser. If I change this over here, I can change the fins. So let me try this with the KRD diffuser, which is the most standard form of diffuser. And I'm going to run my diffuser that I made without fins. So I made this kind of diffuser without fins because it was my version doesn't allow this sort of prediction. But of course, I can come here and change the characteristics of the diffuser, something as creative as I want to imagine. So if I want to do something crazy, I can do whatever I want in terms of. So I can move away from the formulas of the Schroeder diffusers, and I can actually basically come up with something rather different. Probably would give me worse performance, but here it goes. But it just to show you how great this software is. Okay, thank you for watching. Don't forget to subscribe and stay tuned for further videos in the future. Thank you.